Okay, now we're going to talk about sample size for a mean. So sample size for a mean, this is when we have not done the study yet, we don't have a sample yet, and we're just wondering how many do we need to collect? How many do we need to survey? How many do we need to look at to ultimately figure out something about the population? So our formula is n, our sample size has to be at least z times the standard deviation over the margin of error, square the whole business, and round up. So we're back to z instead of t just for sample size, and that is because we are assuming we know the population standard deviation. Now, of course, we don't usually know the population standard deviation, but you have to ask the scientist or come up with an estimate of the population standard deviation, either from a pilot study, the literature, but you have to somehow or some way come up with an estimate of the population standard deviation. So z we can use because we're assuming we know the population standard deviation. So z will be our old friends of 1.645, 1.96, or 2.576. Here's the population standard deviation, which we are assuming is true. M is the margin of error. That's how much error you can live with. That's how close you want your ultimate sample mean to be to the population mean. How far off can it be before it's unacceptable? So you have to give some idea of how close you need to be. Once you have those three numbers, you plug them in, square them, and round up. So I gave an example. In 1998, Nabisco announced a 1,000 chips challenge, claiming that every 18-ounce bag of their Chips Ahoy cookies contains at least 1,000 chocolate chips. We want to see if on average the bags contain 1,000 chips. How many bags of cookies do we need to buy? Sample size. How many bags of cookies do we need to buy if we want to be 95% confident? Okay, well, if we want to be 95% confident, then z equals 1.96. That we're within 25 chocolate chips of the true average. We want to be within 25 chocolate chips. That's the amount of error we can live with. That's the furthest we're willing to be off. Let's see. And then the standard deviation of the number of chocolate chips in bags of cookies is about 100 chocolate chips. So our standard deviation is 100. So we plug all that in. So 1.96 over 25 times 100. Square the whole business. And we get 61.5. But we can't sample half of a bag. We need to always have a whole number for sample size. You can't sample half a person or half of a lot of different things. So in this case, and in every case, we round up. So we would need at least 62 bags of cookies, at least 62 bags of cookies. If you couldn't afford 62 bags of cookies, there are a few things you can do to reduce the sample size. You could reduce z. Instead of being 95% confident, say, well, I'm actually willing to be only 90% confident down the road that I catch the thing. So then z would be 1.645 and your sample size would be reduced. Or you can say, well, I don't actually need to be within 25 chocolate chips. If I was within 50, I'd be content. So if you increase the margin of error, you can also decrease your sample size. So there are things you can do to decrease your sample size. Usually we can't do much about the standard deviation, but if you could decrease the standard deviation, if you could increase precision, then you could also get away with a smaller sample size. So sample size for a mean, this is the formula we're going to use if we're wondering how many do we need to do to sample in order to figure something out. How many do we need? And then we just look for three numbers, square them, round up, and we've got it.